Right. Welcome to 1114 Physical Geography Exam 3 review. So this review is very helpful, but it is the outline that you need to go back again and emphasize on the materials that would be in your exam. So please be assured that this review when I emphasize on some of the materials, then you go back to the lectures and go back to your book and just read. And I think that you will do a very good job in your exam if you follow what exactly I says. So it would be very much helpful. So best of luck. Let's begin. So very important topic here, that is the types of rocks. So igneous rock, sedimentary rocks, metamorphic rock. Make sure that you understand each of the rock forming process. So igneous rocks mostly we find from the magma is coming to the surface and coolifying, solidifying very fast. So this is the way we get igneous rock. Rocks are hard. Most of the surface rocks that we see, those are igneous rock. Then sedimentary rocks, actually it takes several processes. So it takes erosion, it takes deposition, it takes compaction, then lithification, and finally it become sedimentary rock. So there are stages to form sedimentary rock. Make sure that you understand those things. And then metamorphic rock is that either igneous or sedimentary rock or metamorphic rock itself, under immense pressure and temperature, is formed in different types of rocks. That's metamorphic rock. So metamorphic rock can be formed from igneous rock, metamorphic form can be sedimentary rock, or metamorphic itself. So make sure that you understand all this. Now you see here the topography, land from geomorphology, relief, and uniform sorry so uniformitarianism. So that's mean all these things actually we talk about in the geologic process. Now the order of the relief. So in your lecture that you know that the order of the relief, first order, second, third, fourth, and fifth order. So all the order is coming, shrinking down and narrowing down the process. So make sure that you know all these things. And I will say the next, the internal process. So make sure that you have a very good understanding about the different types of plate boundary. So here the three types of plate boundary that you have learned from this course, that divergent plate boundary, convergent plate boundary, and transparent or transform plate boundary. So make sure that each of the plate boundary, the definition, and some of the example that you know very well. So first, the divergent boundary, that is actually from magma from the asthenosphere, that's well up in the opening between plates. So this upward flow of molten materials produce a line of volcanic vent that actually split out basaltic lava on the ocean floor, and with this rock actually we get that. So we have mid-oceanic ridge as an example of plate, mid-oceanic ridge as an example of divergent plate boundary. Another one is continental rift valley. That's we have. So we know that internal process, we have inner core, that is the radioactive materials, very hot, and that convective way that's coming up, and that actually pressuring on the plate, and this is causing plate to split two-way. So diverging plate boundary, the motion of the plates actually they are going away from each other. Make sure that you know this definition, that would be helpful. So the second one is convergent plate boundary, most important plate boundary that we see, the mountain range, Himalaya mountain range, Rocky mountain range, those all are the resultant of the convergent plate boundary. You see Nazca and South American plate actually colliding with other plates, and that's the different types of mountain is forming. So Nazca plate is moving eastward and is causing what? The Rocky Mountain to grow because it's colliding with North American plate. On the other hand, South American plate is colliding with that on the ocean and converging that. So make sure that you know that. And the most important things about the convergent plate boundary is their subduction zone. So one plate is going under the another plate, and in this process there is a lot of pressure, vent, volcanic eruptions is happening. So subduction zone is a very important part of the convergent plate boundary. So make sure that you know all these things. The last boundary, that's called transcurrent plate boundary, or um, transform plate boundary actually. So this one is actually the two plate boundaries is moving parallel to each other but in the opposite direction. So this is not much violent than the diverging and converging, but that happens in somewhere in California, that we call San Andreas fault. So make sure that all three definition and occurrence and example that will be in your questions in your exam. So make sure that you know all these three types of plate boundary. As you know, that's a cause of crustal stress that you have learned from the lecture. So there are different types of pressure that is making the different types of landform. So tensional stress, this one is actually one directional stress that happens sometime when your earth crust is moving in one direction. So then we have confining stress. That's mean you have equal pressure from every side. So that happens, and sometime in the metamorphic rock we find that. And then shear stress, you can imagine that is related to the transform boundary. Excuse me. So transform boundary sometime that you know that is opposite direction of the movement, but this parallel. So these types of shear stress is similar to that sometimes happens. And another one is a compressional stress. So this compressional stress is actually making different types of landform that you will know. So types of fold, make sure that you know each of the fold and cause, and also know why those are happening, because there are two questions on that. So some that types of fold, that's a monocline fold. That's mean in the sedimentary rock you will see that monocline that is actually going down in one direction. That's kinds of fold is happening, pressure. And then you have anticline fold. Anticline fold, that's mean that when the two side of the compressional stress is acting on a rock or on a landform, actually it is going up, is coming upward. That's anticline. And then syncline is actually the opposite of the anticline in terms of the direction. It's going down. And another one is actually overturn, because sometime it's so much pressure pushed one rock layer to actually slide over the another rock. So make sure that you know all these things. There are two questions on that. So make sure that this type of fault that are actually related to the fault that you have learned. So normal fault, that's kind of fault actually happening because of that tension, that's tension stress. Or you can relate with the boundary, that's called divergent boundary. So the two rocks are splitting away, going away each other, and this tension types of fault actually fault creating, and this is causing because of the lack of the materials due to the tension. So another one is reverse fault. Reverse fault happens when compressional stress is acting on is. And then the transform fault, that's actually shear stress that's acting on. And then again the thrust fault that is happening due to the transform types of boundary. So make sure that the fold and fault and the stress are interconnected and interrelated to each other. There would be question from there, so make sure that you understand that. So another important topic, that is earthquake. So we know that the earthquake happen in different way. So plate boundary as moving, divergent plate boundary, convergent plate boundary, there is a subduction zone, so there's a lot of pressure in volcanic eruptions and fault. Everything is responsible for earthquake, but um, the structure of the earthquake, if you look at, there is a focus. That's mean the focus is the origination of the earthquake, and the epicenter is directly above the focus. So make sure that you know the epicenter is the location on the surface directly above the earthquake focus. So earthquake has different types of scale. Will be you need to know that. So make sure that you know the basic structure of the earthquake. What is focus? What is epicenter? And where the earthquake intensity felt the greatest amount. It is not in the focus, it is at the epicenter. So make sure that you know all these things. Okay, when we talk about the earthquake, we have a scale. So two types of scale that we measure. Just make sure that you know that one is in magnitude, another one is intensity. So magnitude, the Richter scale, and intensity is more like damage or something. So Richter scale, make sure that you know each of them. So Richter scale represents size, the earthquake, but not necessarily the damage. But Mercalli is actually representing damage. So you know, make sure that you know the differences. So Richter scale determined by area, fault, and how much it slipped, and it determines the observation of the shaking or damage. So you see that Richter scale has the decimal point 6.7, 1.2, 3.2, 10, 10 is the highest. So is a single earthquake, we have that. In here, the Roman number, the Mercalli actually we represent with the Roman number 1 to 10 that use. So it's depending on the location. So make sure that you know the difference between the Richter scale and the Mercalli scale. Now Richter scale, we know that in the Richter scale actually is a logarithmic scale. That's mean from 1 to 2, the difference of the in magnitude is actually 10 times. That's mean earthquake 2 is 10 times greater than the earthquake 1. Earthquake 3 is 10 times greater than the earthquake 2. So this is how actually Richter scale works. So Richter magnitude 1 to 2 is 10 times, then 2 to 3 is 10 times, then 3 to 4 is 10 times larger. So it's actually logarithmic scale. So when you see 5 Richter scale magnitude and 6, that's mean 6 is 10 times bigger than the 5. So make sure that you know, understand that changes, that Richter scale earthquake measurement. So in from the earthquake, you need to know focus, epicenter, the where is the maximum felt, the shaking, and you need to know the differences between Richter scale and Mercalli scale, and how Richter scale actually we understand Richter scale magnitude. So volcanism, make sure that you know the types of volcanism. So there is two types of volcanism. We know that extrusive, which that the magma underneath the earth crust is coming out, which become lava. So make sure that you know the difference between magma and lava. There might be a question for that. So extrusive is coming to the surface, and intrusive is actually keeping that lava, actually not lava, the magma is inside the crust and coolified and making different types of land from. So those are volcanism. And you see that you have extrusive volcanism, intrusive volcanism. So in intrusive volcanism, there are some different types of landform we find inside the earth crust. So one of the most important is batholith. So batholith is the most abundant, so the largest deposit of intrusive igneous materials inside the ground. And then you have a stalk. A stalk is kind of things that you are looking at over here. This is the stalk. And then you will have some vent. That's we call it dies, and make sure that you know other steel and vein, all this. There would be a question, one or two from here, so make sure that you know intrusive volcano. Then extrusive, sorry, the type of volcano in terms of the activeness. There are three types of volcano: active, dormant, and extinct. So active volcano, that we know that is happened in recent year and it can happen anytime. The dormant is something that it's happened a long time ago, but there is a possibility that will happen again. But extinct is only the landform right now exists. There is no chance that volcanic eruption can happen from this landform. So make sure that you know all these things. So eruption types, if we are talking about the eruption types, at the same time volcanic eruptions and also the volcanic landform is related with that. So composite, explosive, caldera, then you have cinder cone, you have shield volcano. Shield is the most common volcanic landform we see. So we have the extrusive volcanic feature, the different types of. So make sure that you understand all of them. And um, the one of the volcanic eruptions that might happen, let's say we know that Yellowstone National Park, the super volcano may have happened. So it's happened, assumably geologist says that 70 I think 70,000 years ago. So it may happen again, but if that happened, that would be the secondary ash zone, this primary ash zone, and that would be the kill zone. That's been everything on the kill zone will instantly die. So that's the important things that I just wanted to make sure that we have in the United States a super volcano in the Yellowstone National Park, Wyoming. So make sure that you know that, but there is nothing to worry about. It's not gonna happen. I believe so. Okay, so make sure that you all understand and know before the exam. There are some questions, so make sure that you know that. Now you may want to know what types of proximate question would be from the soil chapter. So there are a lot of questions in your exam from this chapter, so make sure that you have attention on that. So let's begin. First, the 5 soil forming factors. So you make sure that you know each of them. So geologic factor, about the internal process, intrusive, extrusive, igneous rock forming, and what types of loose materials over that depending on how the soil will form over time. So that is the one factor. Another factor is climatic factors. That means that soil has different formations in different climate region. So soil are more prone to develop in the tropical region because of the more weathering process happens due to the intense chemical and physical weathering. And topographic factor is another factors that important in the mountain, in the valley of the river, in the some sort of region that you know that erosions, depositions, river formations, everything are topographically related. So biological factors are related with the microorganisms. So bacteria is the most abundant active soil forming biological factors. Remember, bacteria is the most active biological factor for soil forming, so make sure you know that. And then you have fungi, you have algae, you have root materials, not root materials, I meant it that root of the tree, everything are important. So chronological factors means that time is talking about. So you know all these things, so make sure that you review those lectures and make sure that you have information. So we have questions from here. And then soil components. So another things that I would draw your attention, that you need to know what is the difference between component and the particles. So components, that organic materials, inorganic materials, soil, air, and water, those all are components. But when we talk about soil particles, that's mean we are referring to sand, silt, and clay and gravel. So particles, those are the particles, and components are inorganic materials, organic materials, air, and water. So make sure that those two things in your questions you do not mix up. Okay. All right, so here the texture, silt, salt, and silt, sand, and clay. Okay, so all these things, and you see the particle size, and those are the properties here: color, texture, structure, colloid, acidity, all these things. So make sure that you know difference between component and particle. So another things that soil moisture. So if you are looking at over here, we have gravitational water, capillary water, hydroscopic water, combined water. So gravitational water are mostly gravitational and capillary water that tree can take it very easily, but the hydroscopic water actually tree is not available for tree. It's very much difficult for tree. So make sure that you know this difference, and make sure that each of the water definition and also description in the lecture you reviewed that. There are questions from there, and some of them I actually hinted you. So yeah. So you see the gravitational water, elevation, leaching soil, all these things. So it's coming from there this way, and then it depends. If you have that gravitational water much, the tree grow very well. Okay. So soil properties, color. So you already did that in your lab. The soil color, soil, how the color actually defined. So you know that. And acidity, you see that United States in the western side, if you draw the border line in the middle of the country, the eastern side is acidic soil compared to the western side of the country. So the acidity is very important for plant growth and also soil formation. So if you know that, and then you need to draw your attention of the soil profile. So mature soil and immature soil. So in a mature soil you have O, A, E, B, C, and R horizon. So R is a completely bedrock, C is a disintegrated bedrock, and B horizon is, you see the difference between soil profile, the mature soil and the immature soil. Make sure that you understand the mature soil has B horizon, immature soil doesn't have that B horizon. And you see O horizon is organic materials, and A horizon is a leaching um, materials, and you make sure that's the difference between mature soil and immature soil. There are two questions on that, so I'm giving you these two questions, so make sure that you understand that. Okay, now the soil forming regime, that's mean different types of soil formation happens in the different region. In the Oklahoma we have calcification for forming process. So make sure that you understand calcification, and also in a lecture it is elaborately described that glaciations, lateralization, all these things. So if you know that, that would be very good for you. Okay, now soil has been classified in 12 classifications. So this 12 classification, that hierarchy system, soil order, that actually 12 worldwide. So that process is called the seventh approximation. So make sure that you know that name. Seventh approximation is the process, that soil classification process took place. It's worldwide the same thing. Okay, now soil classification, you have 12 types of soil in here. Make sure that you understand some of them. So I'm not expecting that for the exam purpose you have to understand each of them, but make sure that the main soil you understand each of them from here. There are questions from there, so make sure that. So weathering and mass wasting, make sure that you review that chapter 2. Here the most important, like internal process, you already have learned that. And external process, weathering and mass wasting. So internal process, make sure the distinction between internal process and external process. So plate tectonics, volcanic eruptions, all these actions are happening in the internal process. External process is mostly derived by the weathering and mass wasting. So weathering, there are two types of weathering: mechanical weathering and chemical weathering. Other types of weathering, we call it biological weathering, but biological weathering actually fall into both mechanical and chemical weathering. So some of the geologists actually do not um, distinguish or separate these two. Sorry. So mechanical weathering, frost weathering, that's mean freezing and thaw, happens mostly in the higher latitude and higher altitude or higher elevation. These types of weathering, we get that each year, so make sure you understand that. Then salt wedging, that salt actually make the expansion and compaction, so salt wedging. And then thermal pressure biological, so thermal expansion and contraction in the humid or the dry tropical region. These types of weathering more prevalent, and that actually also include the pressure differences. And biological weathering, we know that tree actually penetrating into the building, or tree is actually cracking the bed materials, and this is the way that weathering process is making from uh, rock to the soil formation. So you make sure that you know all this. So and the chemical weathering oxidation, that's when oxide ion is adding. If you have iron materials more into the soil or the rock, you will have oxidation. Then hydrolysis. So hydrolysis is something that you need to know, that how water is actually chemically reacting with the hydrolysis and some other things. So now the types of mass wasting, um, we know the fall, slide, flow, and creep. All these four types of mass wasting, and we go to the lecture and also the review. All this, there are some questions from here. And then the lastly, I would say the angle of repose for the mass wasting. You need to know that the maximum angle at which a materials can remain at rest on a slope. So that's called angle of repose. So when the angle of repose actually is exceeded, then mass wasting, through the gravitational force, mass wasting happens. So you will be doing very good on this exam. I hope that, and best of luck.